Interesting. Now, looking at your max VO2 data, and I like that you put individual data points here because I noticed with max VO2, I think the control, basically nothing. I mean, slight up, slight down, no change, but everyone when they were exposed to heat, it looks like one, two, everyone improved except looks like one person did not.
Mm.
Um, which is interesting. Do you think based on actually some of these guys have a very high max VO2. What kind of
Mm.
athletes were these? I mean, there's a guy here with 82. Holy jeez.
Yeah, one of our participants is a 2 hour 12 marathoner.
Wow.
So it was really cool to get kind of someone that elite through the study. So most people were sitting around that mid 60s VO2 max kind of number, so 664, 65-ish. And then yeah, we had one particularly elite runner.
Now, what do you think this would translate to if, let's say, they run a 5K or a 10K in terms
Mm.
of seconds off? Because that's a lot of runners or even cyclists would say, well, what's that mean in terms of seconds? I mean, you'd have to guess because you didn't do a time trial, but what would you think?
Mm. Um, we're probably in the realm of 2 to 4%, I would say, maybe slightly less than that in terms of a performance benefit. Our VO2 max numbers increased by 2.7 absolute, which I think equated to about 4% from 4% increase from pre to post intervention. Um, the only thing we can point to from an actual speed perspective, because we didn't get people to do a 5K before and after.
Right.
The only thing we can point to is that the treadmill speed at VO2 max increased by almost a full kilometer an hour from pre to post intervention. So the speed that people were running at when they were maxing out is faster. So that itself would definitely help you in the long run of a distance running event.
I mean, that's pretty amazing, actually. I
Yeah.
mean, were you surprised that they improved that much?
Yeah, like definitely I had faith that this would work from the get-go. I knew we would see, well, I say knew. I was confident we would see increases in hemoglobin mass. I was somewhat surprised by the increase in left ventricular end diastolic volume and kind of the cardiac adaptations.
Actually,
Um,
let me stop you there. Explain that because a lot of the audience, they're not familiar with cardiac physiology. Explain the importance of that.
So when we talk about left ventricular end diastolic volume, we're talking about the size of the chamber of your heart when it's at its biggest. So when it's just finished filling, so you've got a filling phase and a kind of an ejection phase during every heartbeat. Uh, the left ventricular end diastolic volume is essentially when your heart is the biggest. You've just had the influx of blood from your left atrium. Your left ventricle is as big as it's going to be. It's ready to shoot all that blood out into the rest of your body throughout your aorta. So having a bigger heart allows you to pump more blood out per beat, essentially, and that's more oxygen being carried around to your working muscles. So if you can effectively increase your oxygen delivery by way of increasing that kind of stroke volume, um, it's going to serve you well kind of for exercise and maximal exercise.